Morning guys, today we're going to look at some tips and tricks for the 3 times tables. Now, as is often the case with many of these things, one of the best things you can do is memorize the 3 times tables, and the way to start with that is to learn how to skip count in threes. So if we go 3, 6, 9, 12, 15, 18, 21. Have we got enough room on our screen for that? Oh yes, we're going well. Then 24, add another 3, 27. Come down a bit. Then we've got 3 tens is 30. Might as well go to 12, 33, 36. So we've got our skip counting in 3 numbers there. 1 times 3 is 6, 2 times 3 is 9. 2 times 3 is 6, beg your pardon. 3 times 3 is 9. 4 times 3, 5 times 3, 6 times 3, 7 times 3, 8 times 3, 9 times 3, 10, 11 and 12. Now, one of the things I often do is look for a song. There's plenty of very cool songs you can use to help you skip count in threes or just memorize your 3 times tables. So that's tip number 1. Look for a song. One of my favorites is by Jack Johnson is his name. Tremendously powerful way of learning how to do your 3 times tables. Doing drills on a piece of paper is another one. They might look like very simple things that you get on a sheet, and hopefully your teacher or myself will give you one of those from time to time, and each one of them will have something like this, and you pop your answer in there. Now, an important thing to remember with the times tables is sometimes it'll look like this. When you're talking about multiplication, it doesn't matter particularly whether the 3 is in the start and then the number that you're multiplying by is in a different place. So it could be 3 times 1 or 1 times 3. The answer will be the same. Okay, so look out for sheets like this that you can practice with. But I really wanted to show you today some tricks that you can use when you don't remember. And this is what happens to all sorts of people. So you get a slightly harder one. Maybe you've been asked what 3 times 8 is, and you can't remember. It's fallen out of your head for whatever reason. This happens to adults and kids as well. They very commonly get asked these questions just randomly. What's 3 sets of 8? It's fallen out of my head, I can't remember. So here's a nifty little trick you can try that works really well. Think of your 2 times table. You know 2 times 8, 2 times 8 is 16. You know your doubles already. But it's not 3 times. We need another 8. There's another 8 to go around. So that's okay. We just add the 8 on because we need 3 of them. There's 2 there and 1 there. We can go 16 plus 8. Oh, well, that's easy. That's 24. So your answer to 3 times 8 is 24. That is a really handy little trick that you can use, even if it's a tricky one that you don't really know. The cool thing is it works for numbers that you might not be familiar with from your times tables. Say your original question was something more meaty, something that's designed to catch you out. Maybe, I don't know, 3 times, 15. 3 times 15. Now, some of you who might be familiar with the 15 times table, we know some of you will go, yes, I know the answer is 45. Just pretend that you don't know the answer for a moment. We'll use this as an example. We split our 3 into 2 and 1, can't we? So then we start with 2 times 15, double 15 we know is 30. Add another 15 on. straight away we get 45. So if you can double whatever number it is that's there easily, and then just add another one on, you've solved your 3 times tables. Just a handy dandy little trick. Now, there are a few other tricks too. We'll get onto those in a second. Just give me a second to wipe the board. Okay, the next little thing you can do with the 3 times table or any other times table is to use place value to help you. Once you know your basic facts, say you have a basic one like 3 times 7 or 7 times 3 equals 21. That helps us with our place value, and we can use it like a family of facts. If we know 3 times 7 is 21, we also know then that 30 times 7 is going to be related to 21 somehow. So long as we keep our numbers in order, we know that it's 10 times more. So 3 times 7 is 21, 30 times 7 is 210. It works with much bigger numbers too. So you had 3,000 times 7, your new number would be 21,000. Little tip that you can do here is basically just however many zeros you've got there, just make sure you've got the same amount of zeros on the other side and you'll get the correct answer. Works with tiny numbers too. Say you are going to multiply 3 times 0.7. The decimal there just tells you that we're talking about a part of a number. We're going to end up with 2.1. You can see how it resembles 21. All we've done is taken our decimal point, we've taken the number and shifted it along so the decimal point is in between the 2 and the 1. 2 and the 1 in the same order. It would also work if it was 0.3 times 7. Remember, 0.3 in this case would be 0.3 of 7. You can write of in there as a little reminder. 0.3 of 7. It's going to be slightly less than a third of 7. The answer is still 2.1. Makes sense either way you do it. So place value is a tremendously powerful way of dealing with a whole lot of very, very large numbers. Now, over here, you might find that it's this number that is bigger. Maybe it's 3 times 70 or 3 times 700. Doesn't matter. You can still use your basic fact that 3 times 7 is 21 to get the right answer. This is going to be 210. This would be 2,100. Really, really super convenient way of dealing with your times tables and getting a whole lot of other facts that you can use at the same time. Okay, so if you're watching at home, just pause this and have a go. You might want to write it out for yourself. If you know what 9 times 3 is, you can fairly easily work out what the other answers to these are using your place value. So just pause it here for a second, have a go, and I'll come back to you. Right, how did you go? Well, we know 3 times 9 is 27. It's one of our favourite basic facts. We know it's in the 9 times table as well because these two digits add up to 9. 3s and 9s are closely related, by the way. Makes sense. So we know 9 times 3 is 27. That's our basic fact. 9 times 3 is 27, but in this case the answer is 10 times larger, 270. 0.9 times 3 is going to be 10 times less. So we can still write 27 for a start because that's our basic fact. We just need to know what to do with Dennis decimal down here. 2.7 is the answer. You could say 0.9 of 3 makes sense too. It's 90% of 3, 2.7. Sort of makes sense if you think about it. Then 3 times 900. Well, the basic fact is still the same. It's 27. We'll make sure that we've got the same amount of zeros there. Be 2,700 in total. How did you go? Hopefully it worked out okay for you. Okay, what happens if we've got bigger numbers? We might have bigger numbers at the top that we're trying to multiply by, or even ones here where we're multiplying by 30, or even ones by 33. Well, it turns out if you take it step by step, it's still pretty easy. So we'll start with this little guy here. You may have encountered these with the 2s and 5s times tables that we've already done before, even the 4 times tables. The process is the same. It would take it one little chunk at a time, and it works out pretty easy. So we know 3 times 2 is 6. We don't need to carry a 10 over because it's less than 10 is our answer. 3 times 8 we know is 24. We'll put the 4 there, that's 4 tens. And the 2 hundreds up in the other hundreds. We know 3 times 5 is 15, plus 2, 17. Our answer there, 1,746. Remember, when we're multiplying by 10, something that's 10 times bigger, we can do exactly the same process, but if we just almost pop that one down there to remember to change our place value, the process is exactly the same otherwise. 3 times 6 is 18. We carry the 10 up onto the other 10s. 3 times 2 is 6, plus 1 is 7. Don't need to carry anything more. 3 times 7 is 21. Now, we've already shifted our place value along, so we're going to end up with the right answer straight away, which in this case is going to be 21,780. These ones here, pretty much the same, but just with a slight difference that we need to add up what we've done in the first place. So in this case, we'll do our first chunk of maths. 3 times 9, as we figured out before, is 27. 7 goes there. Carry the 2 tens up there. 3 times 1 is 3, so that would be 30, plus another 20 would give you 50. Nothing else to carry over. And 3 times 2 is 6. Pretty straightforward. Makes sense. 3 times 219 is 657. Now we're going to multiply by 30, but we don't have to do all of the maths all over again. We know it's 10 times more to start with. We know 3 times 219 is 657. Just pop those under there and then add those together. 7, 5 and 7 is 12. Carry that up there into the hundreds. Add up all of the hundreds. Basically 6 and 6 gives you another 12. 6 plus 1. Total of 7,227. So pretty quickly, just by knowing your basic facts, you can end up doing some really, really interesting maths. Okay, so have a go at a few of these yourselves. Look out for the decimal here. Now, as we know with decimals, the maths is exactly the same, so it doesn't really change what you do. But have a crack at it, pause this, and come back and see how you did. Okay, let's have a look at these two. So you've got 3 times 8 is 24. Put the 4 down there. Carry the 2. 3 times 2 is 6. 6 plus 8. 6 plus 2 is 8. You know what I meant. Then 3 times 5, 15. Makes sense. If we rounded that down to 500, 500 times 3 would be 1500. So we know that approximately, using estimation, that our answer is in the right ballpark. Now, this one is going to be something close to 3 sets of 64. So if you're going to estimate, that would give you 180, 190 something maybe. So if we end up with that kind of number, we know we're in the right ballpark. First thing I would do though is put your decimal point in there so you don't get lost. So indicating that the numbers here are less than 1. 3 times 7 is 21. Carry that up into the ones column this time. 3 times 3 is 9, plus 2 is 11. Carry that up there. 3 times 6 is 18, plus 1, 19. We ended up with 191.1. Okay guys, I hope that helps you with some of your 3 times tables questions that you've had. have a go, muck around, set yourself some questions if you like to. All right, guys, have fun. We'll see you later on. Bye.